Good day, everyone. My name is Jeho Ricardo from BSCS 2A. So in this video, we are going to look at searching algorithms. So what is searching algorithm? Searching algorithm is the step-by-step procedure used to locate specific data among a collection data. So remember, when searching problem that will require searching algorithm to solve is to locate an element X in the list of distinct elements or determine that it is not in the list. So our solution is the location of the term that equals the value that we're looking for. Our solution is 0 if 0 is not in the list. So an example here would be spell check. Spell check essentially look through all of your items on the list compares to the dictionary. And then the output is gonna put that little red line over something that is under something that is not spelled correctly or is not going to do anything if everything is spelled correctly. So we are going to look at just three of the searching algorithm. Obviously, there are many more. Number one is the linear search. Number two, binary search. And number three is the interpolation search. First is the linear search. Linear search, a very simple algorithm wherein a sequential search is made over all the items one by one. And that one basically just checks each term in the sequence until it arrives at the desired term. For instance, here are my list value and I'm looking at the term X. So the computer know that these are values in sequence. So this would be considered the locations. So in linear search algorithm, the computer going to look first at the first values. So index 0, and they say that not 22. Index 1 is not 22. Index 2 also not 22. Index 3, index 4, and the fifth index is the 22. So what output would our computer give us in a linear search algorithm? The output would be 5. And that 5 means that it is the value in the fifth index. So the things that we should keep in mind in linear search are compares each element in sequence. So keep comparing until it finds the thing that we're looking for. It may be the case that the thing we're looking for is not in there. In that case, we would have to traverse through and compares to every single element before we find that out. Number two, no precondition. Number three, worst case, we search the whole list or array. So the number compares the amount work can be done grows proportionally to the size of the array that we have. Of course, we can also get lucky and find that we're looking for in the very first sequence array. All right, now I've already created a project called linear search and I've typed the common things we have include iostream, using namespace standard, and I have also written stub here for our main function. So what we want to have to do is just create an int array and ask the user to input particular value that we want to search for. And then we will search our array using linear search to see if that value exists or not, and then indicate to the user somehow or another we found the value or we didn't found the value, and maybe where we found that in the array. So the first thing we need to do is just create an array. So we will do int array is equal to 15, 23, 7, 45, 87, and 16. So we have that. So the next thing we need to do is just get input to the user. So we declare a variable. We call user value. So int user value. So then we'll do a cout. And then the insertion operator. And then just say enter an integer. Another insertion operator and then. So we have that display to the user, and then we'll cn extraction operator and then user value. So I think before we write the function call for the linear search, we actually write the function definition right above the main function here, and for the prototype as well. So if we think about this linear search, you probably think, well, we need to pass in the array to this function. We need to pass in the size, and also we need to pass in the thing what we are looking for. So that's really the search parameters. But before that, what we return to this function? So the thing we should return is probably something that indicates where we found on the value, if we actually found the value in the array, or a value to indicate that we didn't find it. So we declare linear search. So pass in int array, and then int size, and then int search value. So we do a recurse here. So for in I is equal to 0, I is greater than size I plus plus. Another recurse, if search value is equal to array I, and then we should return I, then return -1 if not. And now for the function call for the linear search. So we declare the result is equal to linear search pass to A, 6, and the user value. So like this. So in result is equal to linear search pass to A, 6 user value. So if the result is less than or equal to 0, then we should have a recurse again here. So cout insertion operator, the number a result was not found at the element with index. So result and then else cout the number user value was not found and again. So now if we run, the output goes like this. Enter integer, and let's enter an integer that actually exists. So let's say 87, that is exists in the array. And we say the number 87 was found at the element with index 4. So it makes sense that number 87 is in the fourth index. So let's try another one that is not exist on the list. So let's say 10. And we see that the number 10 was not found. So next, number 2, the binary search. So ano nga ba yung binary search? Well, yung binary search is a searching algorithm that takes advantage of the sorted property of the input array. So it runs in logarithmic time, which is super fast, even in large input arrays. So kung hindi nyo pa ito naiintindihan ngayon, don't worry, we will have a visualization about this. So meron tayo ditong example, meron tayo ditong function called binary search. So sa parameters, magpapasa tayo ng sorted array, start index, the end index, and yung item na gusto nating i-search. Okay? So let's have this example sorted array. And then subukan natin hanapin si 25. So the algorithm goes like this. Una, i-search mo muna yung middle element sa pamamagitan nung start at end index. And add mo lang sila and divide by 2. And yun na yung middle element. So dito, sa example na to, ang start natin is 0. And then ang index natin is 6. So 0 plus 6 is equal to 6 divided by 2 is equal to 3. So the middle index is 3, which is 20. Alright? And then we will check the item na hinahanap natin if equal ba siya doon sa middle element. So kapag equal, i-return lang natin siya. I-return lang natin yung index niya. Pero sa example na to, yung 25 na hinahanap natin is hindi siya equal doon sa middle element, which is 20. So ang gagawin natin is, i-compare natin yung item na hinahanap natin kung mas maliit ba o mas malaki siya doon sa middle element. Kapag mas maliit siya, meaning dahil nga sorted yung array, yung hinahanap nating element is somewhere on the left side. Kasi nga less siya doon sa middle element. So, kaya pwede na natin i-ignore yung middle element and mag-focus tayo sa left part. But sa example na to, 25 is greater than 20. Meaning yung hinahanap natin na 25 is on the right side of the middle, which is 20. Kaya pwede na natin i-ignore yung half. Yeah. Now, pwede na tayong mag-focus dito. We will do the same process. Ganun pa rin yung gagawin natin. So, check for the middle element. If it is equal na doon sa hinahanap natin, and then, i-return lang natin siya. So, bakit siya tinawag na binary search? Well, binary means 2. And dito sa algorithm na to, dinidivide natin yung array into two parts. The left and the right part. And depende doon sa value ng mga middle element, mag-move tayo depende doon sa hinahanap nating element. So kapag ang hinahanap natin, is less doon sa middle or mas maliit doon sa middle, then punta ka sa left. Kasi mas maliit nga yung hinahanap natin. And then ignore mo na yung right side. And then divide mo ulit sa 2. Then check mo ulit. Yan. And divide mo ulit sa 2. Ayun. So, kaya siya tinawag na binary search kasi dinidivide niya yung array into 2. And then ini-ignore niya yung other half hanggang makita niya yung hinahanap nating array. So for our code, so include IOStream using namespace. So sa function natin, i-return niya yung index. Kaya ang ilalagay nating return value is int binary search. And then ngayon, ang una nating alamin or mag-i-input tayo ng int sorted array, int start, int end, and then int item. And then ngayon, ang una nating aalamin is kung yung pinasa ba natin is valid. No? So, example, may array 1, may array na A, B, C, D, E, F, G. And then yung mga indices niya ay 0, 1, 2, 3, 4, 5, 6. We have 7 elements. So, dito mapapansin natin na valid siya kasi yung start niya is less than sa end. Paano kung isa lang yung element natin? So, kapag isa lang, let's say B, and ang index niya ay 0. Start sa 0, and then end is also 0. Then, is still valid. So, pwede pa rin siya. Paano siya magiging invalid? So, magiging invalid lang siya if start is less than end. Diba? So, pwede na natin siyang i-return agad, no? Sa negative 1. So, meaning, di natin nakita yung array. So, kapag valid siya, dito na magsisimula yung algorithm. Ang una nating iisipin is kukunin natin yung middle index. Paano natin siya kukunin? I-add lang natin yung start plus n and then divide by 2. So, in middle index is equal to start plus n divided by 2. So, now, kukunin naman natin yung middle element. So, paano natin siya kunin? Int middle element is equal doon sa sorted array na middle index. And then i-check natin if yung item is equal ba doon sa middle element. Then, ibig sabihin, nahanap na rin siya. So, pwede natin siyang i-return yung middle index kung saan natin siya nahanap. So, if item is equal to middle element, then return middle index. Yan. So, now, kapag hindi naman siya equal, check natin kung yung item is less than sa middle element. So, meaning kapag less siya, ibig sabihin nasa left side siya ng array. So, yeah. So, pwede tayong mag-recurse dito, no? Return natin yung binary search. Pass natin yung same sorted array. And then, dito mag-umpisa tayo sa start until doon sa middle index minus 1. And then, pasa natin yung same item. So, else, so otherwise, kapag mas malaki naman yung item sa middle index, mag-uumpisa naman tayo dito ah, sa middle index plus 1 hanggang doon sa end. And then, pasa natin yung same item. So now, i-test naman natin to. Test na natin to. So, gawa muna tayo ng array. So, kailangan sorted siya. No? Int sorted is equal to 12, 14, 15, 25, 45, 67, 72. Yan. So, gawa naman tayo ng variable. Ito. Int result is equal to, tawagin natin ulit si binary search. Pasa natin si sorted. Pasa natin si 0. And then, yung end natin, which is 6. Then, subukan natin hanapin si 45. Now, see out lang natin si result. So, dapat, ang makukuha nating sagot is 4. So, let's run. So, ayun. Nakuha natin si 4. Next, the last one. The third is the interpolation search. Interpolation search is very similar to binary search. So it is an improvement over binary search. So there are few things that we should keep in mind for interpolation search. First, for interpolation search, to work efficiently, the elements should be uniformly distributed. Or in other words, interval between elements should be uniform. So, like in binary search, even in interpolation search, all the elements have to be in sorted order, sorted elements. Now, for the binary search, always check the value at the middle index. But here in interpolation search, may check at different locations based on the value of the element being searched. So we have a formula. Where the formula does is it gives you an index which is very close to the key. I will explain it further with an example. So next, the time complexity. So uppercase O of log 2 n. So this is the average case. And for the worst case is uppercase O of n. Now, let's explain interpolation search with the help of an example. So here, we have an array. Let's name ARR. So the number below is the index, and inside the box are the elements arranged in sorted order. And if you observe closely, interval between the elements are almost equal. Not equal, but almost. So this is the formula that we're going to use. And now we are trying to find the key 28 in this array. So we substitute the given formula. The law represent the lowest index, and the high means the highest index. A high means the value of the highest index, and A low means the value of the lowest index. So the X is the key. This is the element that we're looking for. So in this array, the low is equal to 0. The high is equal to 8, and the A high is equal to 58, and the A low equals to 10. So 0 plus 8 minus 0 divided by 58 minus 10 times 28 minus 10 is equal to 0 plus 8 divided by 48 times 18. So now we can simplify the formula. We get 1 over 6, so which is 8 divided by 48. So times 18 is equal to 3. So this is our answer. Now we can compare 26 and 28. They are not equal, and the key is greater than the current element, which we have found in index 3. Meaning we will choose the right side, and the low will also change. Now the low will become 4, and we will do the interpolation again on this array. So the answer, so the low is 4, high is 8 minus 4, 58 minus 28 minus 28 minus 28 is equal to 4 plus 4 divided by 30 times 0. So the answer is 4. Now we can compare again the key 28 to the value of the index 4. So 28 is equal to 28. Hence, this is the index of the key. Now for our code, include IOStream and using namespace standard. So now we define the function. So in interpolation search, pass in array, array size, in search. So we derive code. So taking to value a first and the last of array. So in low is equal to 0, in high is equal to array size minus 1. So now we start the loop while low is greater than or equal to high and search, less than or equal to array low and search, greater than or equal to array high. And now we do a recursion here. If low is equal to high, recurse again. If array low is equal to search, then return low. So now find the position for element using formula. So in position, in pos is equal to low plus double high minus low divided by array, high minus array low times search minus array low. So if array position is equal to search, then return position. If array position is greater than search, low is equal to position plus 1, else high is equal to minus 1. And then return if not. So now we derive the main function. So we declare n. So in n, cout insertion operator, enter the number of element of array, cin extraction operator, n. So now we create the array. So cout, enter the element, and L. For in I is equal to 0, I is greater than n, I plus. So we do I reverse it here, cin array I. So now for the search, in search, cout, enter to find the element, cin search. So now we're going to call the function. So in x is equal to interpolation search pass to array and pass to search. If x is not equal, then -1. Cout element is present at index. So x. Else cout element is not present in array. So we need to return 0. So now we can execute the program. So if we run this program, the output goes like this. So enter the number of elements of array. So let's say 10 arrays. So we should enter the elements. Let's say 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, and now we enter what we are looking for. So let's say 14. And it says element is present at index 8. So let's try another one that is not exist on the list. So let's say 10. So 6, 7, 8, 9, 10, 11, 12, 13, 14. So let's say 20. So yeah, and we see that the element is not present in array.